The Science Club is conducting an experiment to determine the type of growth for a certain bacteria. At the beginning of the experiment, the culture of the bacteria contained 10 cells. After the second hour, the culture had 40 cells. What is the number of cells predicted after 5 hours by an exponential model? So we start off with our general equation. Y is equal to A times B raised to the x power. And we know that the initial amount is 10 cells. That's what we're given at the beginning. So I'm going to replace A with 10. And we have 10 times B to the x. And we are not given a growth factor here. There's nothing about a growth factor. But we are told that after the second hour, we have 40 cells. I can use that information to determine my growth factor. So if I take 10 times b to the second power, because in the second hour we have 40 cells, I can go ahead and solve for b and figure out my growth factor. I divide both sides by 10, I get b squared is equal to 4, and then I take the square root of both sides to determine that my growth factor is 2. So now that I know my growth factor is 2, I have this new equation, y is equal to 10 times 2 to the x power. Okay, so just to recap, because in the second hour I knew I had 40 cells, I replaced my exponent with 2, that time is the exponent, and I solved the equation for b, knowing that I had 40 cells within the population. And that's how we came up with 2 for our growth factor. Now we can go on to the second part of the equation. What is the number of cells predicted after 5 hours by the exponential model? So what I do is I take this equation, and I replace x with 5 to find out how many cells there are in the 5th hour. And that gives me 320. So there are 320 cells in the population after the 5th hour.